Welcome to the Optimum CAD solution. I'm Pankaj Ratnaparki. Once again, we'll start our free online course that is Plastic Product Design and Advanced CATIA. Today, we are moving towards our next tutorial that is traction motor cover. It's a plastic cover which having the purpose to cover or protect the motor or a similar kind of applications where you require an opening for the exhaust or a suction of an air. So this is the basic design of our cover and we are converting this into the CATIA. So without wasting the time, we'll open the CATIA and start for the designing. So here we're in the CATIA. We'll start from the origin point. After then we'll take the axis system, select the origin point, select the x-axis, y-axis and z-axis and just click on the OK. So this is our the axis. We'll hide the default planes and we'll start for the designing. So as usual, we'll open the generative shape design and we'll starting to extract the surfaces for creating the today's task. Select the sketcher, the positioning sketch, select the origin point and set the orientation as per our requirement. So we'll start from the base. So we'll sketch the rectangle first, which is the base of our particular task, and we'll provide the dimensions as per our requirement. So as per the packaging data or a cover required, we'll apply the dimensions. So we'll use the square 200 by 200 here. Then we'll use the sweep surface directions definitions, and in that we'll use with draft direction command. So with respect to whatever the sweep you required with respect to the draft, we'll use this draft directions. So here you have to select the sketch, then draft directions, and after then just set whatever the direction you require. So here 5 degree of a draft direction we have given. After then we'll take one point which is in the 25 mm 20 to 25 mm above in the Z direction. So we require to create some trapezoid type of a shape here. So we'll extract the lines to create the triangles here, triangular surface. So after creation of the triangles, we'll mirror it on the both side. So 3 lines we have created. We'll join those 3 lines 1 2 3 and we'll fill this triangle so that we get a triangular surface. So the 4 triangles will complete our required shape. So this triangle is going to be mirror or a symmetry with respect to the existing one. So this is the symmetry plane. You have to select properly. So this fill surface, this plane, and here the surface get mirrored. Same way we will fill the remaining portion. So create the required lines. Once the triangle gets completed, we'll join it. Otherwise, without join also, you will fill that surface. Just you have to select the 3 lines at a time. And instead of that, either you can join all the 3 lines and then select as I'm showing. Same way you have to mirror this portion also. After creating of the upper side 4 triangular surfaces and the bottom base, will join all the 5 surfaces here. We'll apply some radiuses. So we'll use the edge fillets command, and as per the aesthetic and the packaging you required, you will apply the fillets. So this is looking much more bigger, so we'll keep it as a 5 mm. So at the next time, this portion will cover the total bodies, or whatever the bigger side of a bodies of the motor. Then we require to create the plate which is going to be mount on any other surface or any other component. So that mounting plate will create, or a mounting that total area we are going to be create. I will just increase that bottom side draft area, that length of that draft area, as we have translate our particular plane 25 mm. So same way we create bottom mounting face, or which is the mating face, where we are going to be mount our cover on the assembly. We are just creating the basic concepts here. So same way we'll sweep with respect to draft direction. As we know that we are creating the plastic component, then definitely we require to maintain the tooling direction. So currently the Z direction of particular, or a default Z direction, is our tooling direction. Same way we will join all the plane, all the surfaces. Then we'll apply some radiuses, that is the edge fillets. We'll provide the radius of 20-30 mm. Now we required to join those two with respect to each other, so that we'll use the trim command, trim definition here. So unnecessary part is get removed. We'll remove the shaft edges by giving the fillets. So select the edge properly, and here the fillets or the basic cover is get completed. Now as you know that the motor having some circular, or a that motor is reciprocating motor which having circular fans or over there, so we required to make such kind of a shapes on our cover also. So as per the diameter we required, we'll keep at a 180 here. So instead of extrude, as we know that we require the draft definitely, so we'll keep at a we'll use at a same with draft direction command here, sweep command with the draft direction. Only we need to check the direction properly here, because it is now we are extracting from top to bottom side here. So here it is exactly clearing the tooling direction, then it's okay. We'll fill the top upper face, we'll join both of the surfaces. Same way we'll create some depression or some extract surfaces at the top side also. And for adding that air inlet or exhaust ribs, we'll use the Boolean operation also, so that this tutorial will mix of a advanced surfacing and advanced Boolean operations or a part design also. So same way we'll close top side surface also. We'll hide this because it will make some proper visualization. So now we need to join both of them, but for joining purpose where as usual we'll use the trim command, but during the trim, so firstly we'll join this, and after and then we'll use the trim command. So before why using this error will become, because at the bottom side you will see both surface here are only in line, they are not mating each other. So we required to extract some at the bottom side of top surface at the bottom side, and then you can see this trim command will perform well here. We'll apply some chamfers here, fillets of a 15 mm. So we need to trim both of them. We need to join those two also. So we'll check whether the 10 mm is okay or not. I think it looks like much more bigger. We'll keep as a 5 mm here. Now finally we'll use the trim command for joining both of the base and top circular portion. So here you can see it get trimmed properly, and we'll apply some fillet at the sharp edges. So here the cover which protect the other parts of the motor or whatever the assembly, it is get created. Now we will move towards closing this total shapes. Before that, as this is the plastic component, so some depression should be there which provide the strength. So at the four corners or diagonally corners, we'll apply some projected depressions. Let's see how it is get created. So we have to create the depression at the diagonal. So we'll take a plane which is exactly which is angular 45 degree with respect to the Z direction. So reference plane, select the reference plane here. You can see the plane, we got a plane at a 45 degree in between the X and Y. So here add whatever the depression profile you required. We'll add here some cylindrical shape here. So whatever the depression you required, you have to add here. Firstly we'll check, and after then we'll finalize the dimensions. So we will create one cylinder which is totally closed, so that we have to use the close surface commands here. So we'll use the fill command here for closing the cylinder. So we can use directly fill command by selecting that edges, as it is only single circular edge. So we have to join all those three surfaces. Oh, something wrong surface gets selected. Only two surfaces. We'll do the joining command once again. So the three surface we need to join. Select that three surface. Yes, it get joined. So we'll use some edges to be filleted here for looking some smooth surfaces. So we'll finalize the dimensions. We'll keep it as a 20 mm diameter. It is a 10, and at the top side also we'll keep as a 110. So it get automatically updated now here. So this will be the we have created the profile at the one diagonal area. So with a simple way, we'll use the complete cone definitions for circular pattern command. Select the direction, and in the 4 instance which having the 45-degree angle each. So once again we'll use the trim command, select the 2 surfaces. Here the depression get created. We'll make some smoothness also over there, but before that we'll complete the total definitions. We'll apply the radiuses at the sharp area. Select properly. We'll keep as a 4 mm here. Okay, so this almost get completed. Now for making the exhaust or inlet, whatever the exhaust or inlet air pockets, we'll create some ribs, and for that we'll once again use the Boolean operations. So that will come into the part design. We'll take some bodies here. Firstly we'll convert this surface. We have closed all the surfaces, so that basic plastic cover will converted into the solid by using close volume command. So here the close volume command, select the surface which is get closed. We'll hide the geometrical set, and here we'll get that the basic closed volume. Now we'll create the remaining portion. We can create that ribs in the surfaces also, but the Boolean operations are much more easier. So that will use the Boolean will come into the solids. So whatever the shape you required, you'll just create here. So we'll create one sketch here which is 25 mm, 65 mm, and this will be the 35 mm. So they like this at the top side we'll use some spherical shape here. As usual we'll take a ribbing portion here by using the pad. So before that we'll create the basic sketch for the ribs. So whatever instances and dimensions we require we can add, but normally we have to keep minimum 20 mm or a 20-25 mm or a 10. It is depends upon the thickness of the rib, but we'll keep as a 20 mm distance in between the two ribs where the area is much more bigger. So we'll use the pad command with the thickness and 1.5 mm thin pad, which is neutral to the with respect to the center. So we'll hide our basic cover, and this area we need to convert into the ribs. So the spherical ribs are get created. Now some strengthened ribs we required, which connects each rib with respect to each other. But before that, as usual, it's a plastic. We required the draft. Select the draft, then pulling direction properly, and the propagation is already the flat surface is the propagation. 1 degree is much more. It is it's okay that 1 degree draft here. Now that joining rib. So either you create the rectangle which having a default thickness, or just create a line. As usual, we'll use a thin pad command. So take a pad command, I activate the thickness, then neutral fiber here. So this whatever instances you required will keep as a complete cron with the 12 instances along the z direction. Draft is missed, so we need to add that draft also. So we need to activate the original original pad of that rib. We'll apply the draft. As usual, we'll keep the propagation and pulling direction, and here the ribs, the basic pads of the ribs get completed. We'll add this both ribs into the one body. We'll keep the name as a rib bodies. We'll add the body 4 and body 5 into that, and after then definitely we need to intersect with respect to that helical surface, or that spherical surface. So here you can see this is the output we got. If I activated this, then it looks much more better. So this area will act as a exhaust if the fan is there in the motor, or where you require some inlet, or you require to take some air from the atmosphere, or whatever the system you have currently. So from this area we will take the air inside also. So this is this strips will protect some bigger elements, or whatever the lips or the pages will not enter into the motor. So as usual, we'll convert the inner bodies and the remove bodies, and we'll make 1.8 or a 2 mm thickness here. So follow the Boolean operations properly. So thus we are creating the remove body which having the negative thicknesses. So as this we are creating the inner bodies, so we'll apply the minus 1.8 mm thickness. Now this we need to remove from the basic bodies, so that will create one final this is the rib bodies, and we have to create one final body where we can complete our final Boolean operation. So here the final cover, we'll add the plastic cover firstly, then we'll add the rib second, and then we'll remove whatever the remove body we created. So it's a rib by mistake, I created a ring. So here we'll add this rib body here, and finally, oh, something get wrong, this do properly. Yes, this the rib will get added, and finally we'll remove this remove body. So there you can see the negative thickness body. So here we got this uniform wall thickness. After only the 4 mounting points are get missed, so whatever the mounting provision you have to add that mounting provisions. If there is a snaps, then you can add some snap features or some directly mounting. So we'll apply some color here, and we'll add the 4 holes for the mounting. So we'll apply the draft direction, and after then we'll see how this part is going to be clear from the tooling with respect to the tooling direction, that is our Z direction. As we have already maintained all the drafts during the basic design, so hopefully this part will clear with the first time. So for that, activate the material mode. So this we need to create, or we need to check whether this component is get cleared from the tooling or not. So here we'll activate the material mode, and where is the draft command? Oh, here is it was in a hidden. So just select the part body or a bodies which you require. So here you can see this green color and this blue color is it will indicate that it cleared smoothly. There is no any red color, although I have kept 0.5 mm 0 to 0.5. Today's video is get completed. Thank you for watching our YouTube channel. We'll try to share more and more technical knowledge related to the plastic product design and Advance CATIA. But before that, you have to subscribe, like and share our videos, and do not forget to hit the bell icon. Thank you guys.